Hello, so today we want to talk about the find the limit analytically. The last time, so through the three different videos, we talk about the find the limit of a function graphical approaches, right? So at the times, what was the summary of that? As long as the function is continuous, like continuous, then you can find the limit here. So one example. So let's say we have y equal to x squared graph here. Then I can draw it maybe something like that. And then let's determine, you want to find the limit maybe at x equals 1. Okay, then. So limit x move to 1 of the x squared graph. Then this become basically here and here 1. So this point become 1 and 1. Therefore, on the left side, in moving, even though it's not exactly 1, but it's moving toward that from the left side to 1 here, then at the same time, the y value moving on the graph. I told you on the graph means y value. And from the right side to also, when it moving toward the right direction here, it going to this point anyway. So as a result, we find out this value is the limit value here. Okay, so I'm gonna say this is 1. Then how can we just get this answer without using graph? So you may think just plugging 1 into here, then that is correct. So in this case, we can say limit x move to 1, x squared becomes 1. Then what about just the limit x move to maybe 2 this time? I'm gonna make another function value, which is the maybe 2x squared minus 4x plus 1, like that. So as you see, this is one of the polynomial function too. Therefore, you are just plugging this into all different axes. Okay? So you understand why, right? Because polynomial case, because their function graph is always continuous, so the outcome value also reflect the limit value as well. Okay? So in this case, we can say 2 times 2 squared minus 4 times 2 plus 1. Therefore, 2 times 4 minus a plus 1, which is a minus a plus 1 equal to 1. Okay, so this limit value also basically equal to 1 here. So likewise, as long as you are talking about the continuous function, then you just input that limit x value into the function. Then that's how you get the limit value anyway. But what about this case here? So I'm gonna give you, so fx equal to maybe 1 over x plus 5, and then we're gonna find out limit value when x approaches to negative 5. So as you know, this function case at x equal negative, not at, so x equal negative 5, that means the vertical asymptote, right? The vertical asymptote. We know that the vertical asymptote divide this function graph two different groups. One is on the negative side, one is positive side. So obviously they are not continuous. Make sense to you? Therefore, in this case, the limit x approaches to negative 5, fx equal to undefined or no limit, basically. Okay? Am I making sense to you? Yes. Now, even though we are covering the same rational function here, so what if I'm giving you limit x move to 0 this time of fx? Then you just plug in 0 into the denominator and double check whether this value is going to be 0, which means undefined, right? Then now you know that 0 plus 5 is not 0. Do you see that? Therefore, just plugging it. So you should understand this one really clearly, because this value not making denominator equal to 0, which means fx function is continuous at x equal to 0. That's what this means. Therefore, you just plug in f0, which is 1 over 0 plus 5, then 1 over 5. Therefore, this limit become 1 over 5. Okay? Then let's think about one interesting question here. So I'm gonna give you gx equal to 3 here. Okay, gx equal to 3. Now, we're gonna find out limit x move to maybe 2 of gx. If you don't understand the graph of gx, then this question can be very difficult. But if you know, this represents one of the horizontal line. Okay, so this means 1, 2, 3 here. So that should be our graph for gx. Then this limit become piece of k. So in gx case, no matter what x value is, our outcome is always 3. Therefore, at x equals 2, from the left side or right side, they are approaching exactly same value, which is 3. So this limit become 3 basically. Am I making sense to you? Yes, please. So don't think limit is hard. So you can think about many different conditions, but major two condition is you just to find out whether the given function is continuous or not at the given x value. Then based on that, you can answer that. Otherwise, you may measure, oh, this is the effect by maybe vertical asymptote, or this is starting point, like a radical function. Then you may be able to find out the answer with no limit, something like that. Okay? So I hope it's clear to you. Okay? So let's look at one more question, which looks more complicated anyway. Okay, so given hx, which is x squared plus x plus 2 over x plus 1, and then we're going to find out the limit x move to 1 here. Okay, so that's number 1 and number 2 case. I also want to say x move to negative 1. Okay, the key point is we don't care the numerator, because the numerator can be any number. It can be 0, it can be positive or negative, but denominator cannot be 0. That is the key point. Okay, so when you plug 1, so I'm going to say hx, plug 1 into here, does it going to be 0? No, right? Then just plug it. Another word, hx function is continuous at x equal to 1. That's why you can just plug 1 into all these x's. Okay, then this become 1 squared plus 1 plus 2 over 1 plus 1. Then this become 4 over 2, so becomes 2. So this limit answer becomes 2. Now, number 2 here. So limit x move to negative 1. When you plug negative 1 here, does it going to be 0? Oh my god, yes. Okay, so it means x equal to negative 1. That is our vertical asymptote. What did we conclude before? At the vertical asymptote, the vertical asymptote divide two different parts, negative side and positive side, so there's no limit exists, right? So your answer become no limit. Simple, right? Okay, that's all today, and then I'm gonna meet you from the different video. Thank you.